Alright, so we start again. I have to delete my previous one. The internet was so bad, so I got disconnected. Alright, so we already started to think about this problem. And my current conclusion is if we find a repeat and we sort the frequencies for every letter. And if we find some repeat, and I just realized one thing. There are only 26 letters. That is a revelation. Because there's only lowercase, so only 26 letters. So when we lay it out and we sort it, it's going to be 26 in length. So I can put everything out from 1 to 26. No, technically from 0 to 26. And as we go along, it goes from small to large. The smallest one, I can put it inside, right? And then the next one comes in, we put, I don't know, somewhere. Yeah, because at the end of the day, we just want to fit, right? We just want to fit everything in its position. So we can put, right? So when we sort it, it's going to be 26 letters, 26 numbers. And if we have something that's repeating, right, what we can do is look to the front, right? Look to the front and decide if there's any room that we can insert in there. Yeah, I mean, I don't see why not. I just take this one out and put it in the value in front. Remember, there's only 26. I think I can just cut it out and push it in. Cut it out and push it in. Huh. Cut it out and push it in. Cut it out and push it in. So what we're looking for? We're looking for the smallest, right? No, the largest value that's smaller than me that I can fit in. Are you saying binary search? We're gonna do it 26 times. Yes, I'm saying binary search. Saying binary search, I sorted it, right? Whenever we have the same thing, then I'll binary search it. If only we have keep a set. So we sorted it, but we also keep a set. So this one comes in, this one comes in, from small to large. And then the first thing we have repeat, we just go -1 if it's in it, -2 if it's in it, -3 if it's in it. Just keep going until we find it. And then we push it in. And the next one, if it's the same, oh, no, we don't have to, because the previous one we already know that it drops. If it repeats many times. So we can have like, what's the previous one? Yeah, so we have a set, and we also have a dictionary to record what's the last one. So if we have the same value, then we can just, yeah. Okay, let me try this solution. I feel never done this before. Okay, let's see. All right, so what do? I have a set. We're going to say scene. That's going to be a set. All right. Oh, we actually need a counter. Okay, we need a counter. And we can say counter equals counter s. And then I just need to sort the values. So vals equals sorted counter.values. Okay. And then what we do is we also say memo is going to be a dictionary. Okay, we say for v in vals, if v not in scene, scene.add v. Okay, else, so v is in scene. Then we say the start value is going to be memo.get v. If we don't get it, then v minus 1. Okay? And then we say while start, right? If start not in scene equals start, and then the rest, so in the rest, right? Rest, it's okay. So eventually we go to start, and then we break, right? That's when we break. So whatever it is, start is the value that we last ended at, right? So if it's from 5 to 3, that means we take 2. So we just say v minus start. So rest plus equal to v minus start. And then we'll go to the next one. If it's not in it, means it's unique, we push it in. We don't worry about it again. And keep going. If it's in it, that means we have repeat. And then, oh, that's what we can do. Just say memo v, right, equals v. Else, then it's in it. So start equals memo v. That's the last value. We ended it here. And then we say, well, start minus 1. Start. If start is not in scene, push it in and do the same thing. Else, right, else, start minus equal 1. Just keep going. And eventually, we'll say, okay, rest plus this. And then we return rest. This is I would say that's like a greedy type of solution. I don't know. Yeah, when you're this time, the brain is just fuzzy, very fuzzy. Okay, the last one. Just 2. Okay, and then S, minimum deletions. Okay, we'll pass the test cases. Let's see if it passes. The rest. Well. Do we need a scene? I don't even need the scene. I just need a memo, right? I just need a memo. If v not a memo, then this. Otherwise, it's in a memo, so we do this. Not a memo. Then we do this. Yeah. We need a counter, but we don't call the counter again, so we don't have to waste another one for counter. Yeah. So simplify it a little bit. I don't know. Test case, and then smash my keyboard. Let's just some general things, and something like this. What else can you think about a test case? That's about it. Try it, see it, if it works. Oh, what the hell? Oh, I think it's just, you're kidding me, internet? Oh, it's alright. I just realized one thing. Because I say, well, start. And then just minus equal 1, minus equal 1, minus equal 1, minus equal 1, right? And then, what if it becomes 0? I need to record it becomes 0, which means it just can no longer. How do I record that? Well, break else, right? I don't have to. I can move this one down here. Okay, let's do that. Oopsie doozy, we have a problem. Huh. Elif memo v. Now I do this. Can do that. Can go else. Then the start equal this. I say, well, start. If it's not, then we break out. If it is, then we just minus 1. Check it again. Minus 1, check it again. Minus 1, check it again. Once we're done, come out as this. How is this not right? It was correct earlier. Now we're right. Now let's go. Take a look. Come on. Oops. Wrong answer. Output 2, expected 3. Huh? No. No. Telling me this one is correct. But I don't want this one. I want this one. This one makes more sense to me. Huh. Interesting. So we have 2, 2, and 2. Okay, 2, 2, 2. The first one's 2, right? And the second one, 2, we start with 2. So while this, if 2, no, 2 already inside, so it becomes 1. Is 1 not, no, it's not. So I break out. So 2 become 1. Oh. You see what's wrong? Two becomes 1. But how will the other one correct? No, we do need a set. That's the thing, we do need a set. Because this is just record if you meet this value, what's the previous one. So yeah, we do need a set. We do need a scene. And then this has to be if it's not in scene. Yeah, so the value is not in scene. If it's in scene, it can definitely be in memo. So if it's not in scene, then we say scene.add v. Otherwise, it's in scene. So we have seen this one before, right? And we've seen this one before. When you say start equals this, doesn't matter what it is, start equals this. And we say while start and start in scene, right? If they're in scene, then we say start minus equal 1, right? We try it again, try it again, try it again, try it again. And so we're done, we say memo v now becomes start. Try this one. What the hell? This one's not right. Well, it's because I didn't do that. So eventually when it comes out, say scene.add start. There we go. That is more accurate. Yeah, the speed could just be because of the internet. Okay, I'm gonna try it again. Yep. That is that. So mainly, I would say by, oh, it's not supposed to be here. Should be LeetCode something. It's a new problem. 1647. So once we take the counter of s, the problem becomes given a list of numbers, at most 26 numbers, how many numbers, how many values, right? How many values need to be deducted from the numbers such that all the remaining numbers are unique. Now, since we're dealing with 26, right? Yeah. So the strategy is that for each number that is a repeat, I mean, in this case, we don't even need to sort it. Now we do have to sort. Wait, do we need to sort? No, we don't need to sort. I think we just, this one shall be fine. Key error. Huh. A V in scene. What are you talking about? Hold on. Do we need to sort? what will happen if we don't sort, which means the bigger value goes in first. Then we say, okay, the bigger value goes in, and then we set it. And that's weird. I don't think it's necessary. What? What value is this? Three, 2. No, what's memo? So V is seen. Okay, so what happens is, first one, V is 3. Memo, I do that. Wait, so 3 is in. So start equals this. Perfect. And then start. That's 3 becomes 2. 2 comes in, right? 2 comes in. And then, no, it's not. Wait, hold on. Seen, I have seen 2. Oh, I have seen. Yes, I have seen 2. But 2 I have not encountered yet. So 2 is in seen. But it's not in memo yet. Memo is if I meet this number, so I can do a quick jump. That's basically what the memo does. So it's not in memo, but it has been seen before. Okay, if it's seen before, but it's not in the memo, I think it's fine. We can just, it's been seen before, but it's not in the memo. I mean, we probably can just say .get v and just v. Yeah, I think this also works. So I kind of don't need to sort. We just find a starting value. If we have this v is something we counted before, then we just do it. Otherwise, yeah. So remember that as a repeat, right? That is, has been seen before. Has been seen before. We must deduct from that value until it reaches a number that has not been seen before. So here we use a little trick to speed up the process if there are a lot of repeats. Right? Basically, each time when a value finally settles down, we record the value and the settled down value. The next time, if the same value is encountered, we pull out the previous settled down value, right? And start a new search from there. Well, O26 ON is to get the counter. ON times something. No, ON is ON. ON plus 26 times the M, the size. Okay, I think this one shall still be right, but if you think about it, if we sorted it, remember, it's only 26. So I think sorted is actually a better one, because if we sorted it, then we can just start with V. Which I believe is faster. All right, so that's that. Look at the solution. I'll call it a day. Until it's unique. That's our solution. Until it becomes a number that is not the same present before. This is not right. It says n plus k squared. Oh, it is k squared. Yeah, it's like if we have all of them have the same, and then we have to go down that many times. So for everyone, we have to go down 1, 2, 3, all the way to k minus 1. Yeah, that's correct. Priority queue. Sorting. So actually it's going to be O(n) log n, right? No, it's also O(n). Frequency and the minimum. Definitely consider dictionary and priority queue. Multiple have the same frequency that only one character can keep all of its instances. All other characters must have one or more of the instances. That's true. We will push the frequency of each number into a max heap. And at each step, we will compare the top two elements. If they're the same, we will decrement one of them and then push it back into the heap. Every time we detect that the top two elements are equal, it will increment the variable. So what we're saying is we'll keep a max heap, right? And then if we have some value, it's in the top, if it's unique. If it's unique, then we can just pop it out. So we pop the top two, right? That's the starting point. If they're the same, if they're not the same, then the top one can just throw away. That one is good. Then we pop the next one. Then we compare. And if they're not the same, if they are the same, then one of them, you decrement one and push it back. and pop out again. Decrement, push them back until it's going to be different. Now we push this away. So basically, we are decrementing until it's different, until this one's unique. Makes sense. That's the priority queue. And I'll have sorting. I'll have one more. Oh, tomorrow is going to be have more tasks because I only want to do one more, and then I'm going to call it a day. So this is the priority queue solution from the official solution. All right, port heap queue. Okay, so we say heap equals this, right? Probably gonna turn into a list, and then heap queue dot heapify heap rest equal to 0, and then current equals heap queue heap hop heap. Ooh. Minus v for v in counter s dot values. Okay, that's the one. Okay, so we just say while heap, because eventually heap will be pop out, right? And we say next equals heap queue dot heap pop heap. If current is not equal to next, right, then keep going. Current equals next. Keep going. Else, then heap queue dot heap push heap. I'm not changing current. Next plus 1. Make it smaller. Push it in. And res plus equal 1. Eventually, you want to return res. Oh. Hold on, man, this is not right. I haven't even defined heap yet. Oh, 4. So I have on plus k log k, because every time this is a log, this is a log, and I have k of them. And right, 39. That the understanding is not right. Interesting, this one's not right. Maybe it's a zero handling. Yeah, I think it's zero handling. So next is if we make current to 0. Current is the biggest so far. Okay. What can I say? Wow, heap and current. Whenever current becomes 0, that does mean it's no good anymore. Yeah, that's the one. No. I'm scared. Important to stop early when curl equal to 0. Okay, that'll be it. I might take a look at the last one tomorrow, but that's it. Can't handle this anymore.